We just finished in Module 20 learning about 3 different ways we could prove triangles are congruent. We had angle, side angle, we had side, angle, side, and then we learned side, side, side. And now we're going to learn angle, angle, side. And this is a picture of what angle, angle, side looks like. If you have 2 angles, you can see here that we have angle B is congruent to angle, looks like L, and angle A is congruent to angle K. But you can see the side that we have is not the one that's in between the angles. So this is a non-included side. It's off to the side here. So we have an angle and a side. And we have an angle and a side. And here's how this works. There's 180 degrees in a triangle. And if these 2 angles add up to some number of degrees, let's say that this angle plus this angle adds up to 100. And let's say that this angle and this angle, since they're the same, they also add up to 100. Well, if there's 180 degrees in a triangle, then by default, these 2 angles have to both be the same because there's 180 degrees in a triangle. And then we essentially have angle, side, angle. You have angle, side, angle, because I could make the determination that these 2 80-degree angles are also congruent. So angle, angle, side is just another variation of angle, side angle. But if I wanted to use angle, side angle in a proof, it might take a few extra steps. So if we have 2 angles and a non-included side, we're going to prove the theorem, and then that'll be enough to determine that 2 triangles are congruent. Okay, we're going to go ahead and prove the angle, angle, side congruence theorem. Here you can see that I have angle A and angle C are congruent to angle D and angle F. And here's how this works. In order for me to show that these 2 triangles are congruent, I have to actually go use something else that I've already used, which is angle, side, angle. Okay, angle, angle, side is just a variation of angle, side, angle. And we already now have the idea that if I know these 2 angles and I know these 2 angles and they're congruent, there's only 180 degrees in a triangle, then by default, this angle is going to have to be congruent. Angle B is going to have to be congruent to angle E. And that's what we're going to show. Let's take a look at the first statement. We got angle A is congruent to angle D, and we got angle C is congruent to angle F, and that's part of our given statement. I'm just looking at that statement right there. And then we got BC congruent to EF, and that's what the tick mark shows. And now we've got the fact that angle A, angle B, and angle C all add up to 180 degrees, and this is called the triangle angle sum theorem, and all it says is there's 180 degrees in a triangle. And therefore, if I want to solve, I don't know angle B. Notice angle B we don't know anything about, and I'm going to show something about angle B and angle E. But in order for me to do that, I got to get angle B by itself. And so if I were solving an equation, I would subtract away the angle A, and I would also subtract away angle C. And that's what this says. Measure of angle B equals 180 degrees minus the measure of angle A, and then also minus the measure of angle C. And that's just subtraction because we're just solving an equation. And let's go jump over to the other triangle. I know that just like this one said A plus B plus C is 180, so is D plus E plus F. Angle D plus angle E plus angle F. And angle E was the other one I didn't know anything about. So again, we're just going to subtract things away. 180 minus the measure of angle D minus the measure of angle F. That's the other angle. And that leaves me with E, because in the end, I'm trying to make a conclusion about angle B and angle E. Well, I'm going to go back to the given statement here, which was that angle A was congruent to angle D. And now look at what we're saying. Now we're saying the measure of the angle A is equal to the measure of angle D. Now we're actually talking about degrees. And the rules, sometimes these get a little bit cumbersome. If angles are congruent, then their measures are equal. That's really what the idea is. That's our reason. Their measures are, and I'll abbreviate with an equal sign. Now let's take a look here. We had 180 minus the measure of angle D minus the measure of angle F. Well, look, The measure of angle D is the same as the measure of angle A. So I want you to picture that there's kind of an A right there. And I already know that F and C are the same, so I want you to picture a C right there. And that's what this is. All we've done is taken this statement right here and substitute in place of D and F. I replaced it with an A and a C. So that's just the substitution property of equality. I'll abbreviate it like that. And now we're going to make a determination about the measure of angle B. You see, I already said B was, I put this statement right here. I already said angle B was equal to 180 minus A minus C. Well, here's the same 180 minus A minus C, but now it's also the measure of angle E. And now I'm going to make a determination by substitution that the measure of angle E is equal to the measure of angle B. Now, we've already talked about the fact that transitive property and substitution property sometimes get used interchangeably. I'm a bigger fan of just calling it substitution because that's about what we're doing, but you could call it transitive property and it would mean the same thing. Well, if the measures of angle E and B are the same, then the angles are congruent. If angle measures are equal, then the angles are congruent. Once I show that angle B and angle E are congruent, I'm going to go ahead and put 3 little tick marks right there. And now look what I have, angle, side, angle, angle, side, angle. So we used angle, side, angle to show that now I can use angle, angle, side, and I don't ever have to go through all these steps again. This is how angle, angle, side gets proven. We prove it with other things that we already know to be true. Just to build on the fact that angle, angle, side is really just a variation of angle, side, angle. This question is asking, how could we use this third angles theorem, which says if 2 angles of one are congruent to 2 angles of another, then the third angles have to be congruent. Well, if 2 angles are congruent, therefore you would know the third. As long as you knew one side of a triangle, it wouldn't matter which side they gave you. If I knew that this side was congruent to this side, and these were the 2 angles that I was given, if I automatically knew that this angle here was congruent to this angle here, then this side automatically becomes included. So whereas before it wasn't an included side, if I could make the determination that the third angles are also congruent, all of a sudden this side would be between 2 angles I know. And then I can use angle, side, angle. So angle, angle, side is just a variation of angle, side, angle. But if I do know angle, angle, side, then it does simplify making 2 triangles congruent, creates less steps. So we're looking at a proof, and we've got a couple of parallel lines. We've got M is parallel to N, and if you remember that when we have parallel lines, we have things called alternate interior angles. Those are congruent, and we have corresponding angles. Those are congruent. We have same side interior angles are supplementary. In this one, we're really just going to need the alternate interior angles portion of some of those parallel line ideas. If this line, I'm going to go ahead and add, sometimes we add little triangles to the line to show that they're parallel. And you can see that I already started with the given statement, and they gave us that AC is congruent to EC. And so they ask us to use angle, angle, side. So that's what we're going to do. We're going to go ahead and use angle, angle, side. And since I have a side, now I need to show 2 angles are congruent. So I'm going to use this angle right here. I'm going to use this angle. I'm going to call this angle CAB. And that's going to be congruent to this one up here, CED. And the reason is that they are alternate interior angles. And so I'll go ahead and write an angle CAB is congruent to angle CED. And there's another pair though, for the exact same reason, so I'm going to lump this onto the exact same statement. And that's this little guy up here and this little guy down here. CDE, angle CDE is congruent to angle CBA. And the reason is, if two parallel lines, and we can kind of abbreviate this a little bit, if two parallel lines are cut by a transversal, then we know alternate interior angles are congruent. And that's about as much as we can abbreviate there. And you'll notice now that between these two diagrams, I have angle, angle, side. And I have an angle, and a non-included side. And so my last statement is just to say that triangle ABC is congruent to triangle EDC. And the reason is by angle, angle, side. That's it.